Hi, I'm Dr. Saroja, retired professor in chemistry. Today I'm going to discuss the terminology of thermodynamics. Thermodynamics is the branch of physical science that deals with macroscopic systems at equilibrium. It does not deal with microscopic systems on atomic and molecular level. That is why it belongs to classical physics. It deals with large scale bulk properties, macroscopic properties of a system which are measurable, such as volume, pressure, temperature, and specific heat. It deals with heat and other forms of energy, relationship between all forms of energy. It deals with heat, work, temperature, and their relationship to energy, entropy, and all other physical properties. Let us see what is state of a thermodynamic system and what is change of state. State of a thermodynamic system. In the macroscopic approach to thermodynamics, state of a system is described by state variables. What are state variables? Pressure, temperature, volume, internal energy, enthalpy, and entropy are state variables. What is change of state? In thermodynamics, a process is referred to as a change, a transformation from the initial thermodynamic state to a second thermodynamic state or final thermodynamic state, which is described by the state variables. The change of state can be easily observed by the change of state variables like pressure, volume, and temperature. What are the two types of thermodynamic properties? These are introduced into physics by German writer George Helm in 1898 and by American physicist and chemist Richard C. Tolman in 1917. The first property is extensive property. It depends on the amount of the matter in the sample or size of the sample, hence it's called extensive. Intensive property. Intensive property is independent of the size of the sample and is used to identify the substance and can be easily observed. For example, temperature is an intensive property. Temperature, if you measure of a drop of water, is the same as the temperature of a glass of water or temperature of a drum of water. It does not change with the size of the sample. Let us see in this table various extensive and intensive properties. Extensive properties: mass, weight, size, volume, internal energy, enthalpy, entropy, length, all these depend on the size of the system, hence they are extensive. Intensive properties: color, odor, luster, temperature, solubility, refractive index, pressure, density, boiling point, melting point, surface tension, viscosity, malleability, ductility. These are all intensive properties. They are independent of the matter in the system. These are called intensive properties. Let us see now the various types of thermodynamic processes. There are four types of thermodynamic processes. The first one is isobaric process. Iso means same, baric is pressure. So isobaric process is same pressure process. Pressure is kept constant. All open reactions that take place in the laboratory are isobaric processes because they are exposed to the atmospheric pressure, that is 1 atmospheric pressure. This is an isobaric process. The lid is open and the reaction is exposed to the atmospheric pressure, that is 1 atmosphere. Pressure is constant, hence it is isobaric. Let us see what is an isochoric process. Iso means same, choric is volume. Volume is kept constant. Reaction takes place in a cylinder with a fixed piston or the lid of the reaction vessel is closed. Volume is constant. So this is an isochoric process. What is an adiabatic process? Heat is constant. The reaction flask is insulated. No heat is absorbed or evolved. Q is equal to 0. This flask is insulated and the reaction is taking place inside. Heat can neither go in nor come out. So this is an adiabatic process. And the last one is an isothermal process. Iso means same. Thermal is temperature. So temperature remains constant. The system is kept in a thermostat to maintain the constant temperature. Here it is an isothermal process. The reaction flask is kept in a thermostat and it is being heated. If the reaction is exothermic, heat is liberated and that liberated heat is taken up by the thermostat. And if the reaction is endothermic, heat is required and that required heat is given by the heating coil of the thermostat. Hence, the temperature is maintained constant. So, these are the four types of thermodynamic processes. Now let us see the conventions that are followed in thermodynamics. Let us first see the conventions of heat. Heat is a form of energy. Heat can be absorbed or evolved. Now let us see the first case where heat is absorbed from the surroundings. Ice melts into water. The energy of the system is increased. It is an endothermic reaction. Hence heat is given, Q is given a positive sign. The other one is exothermic reaction. When water cools down to ice, heat is evolved from the system to the surroundings. The energy of the system is decreased. It's an exothermic reaction. Heat Q is given a negative sign. Here ice melts, which is an endothermic reaction, and here water frozen to ice is an exothermic reaction. So this is the sign convention for heat. Now let's see the sign convention for work. What is work? Work is the transfer of energy by a force acting on an object when the object is displaced from its position. Let us take the case where there is a gas in a cylinder with a piston. When the piston is pushed down, work is done on the system by the surroundings and the energy of the system increases. Hence, work is done on the system. Hence, work done on the system is positive. When the gas in the cylinder pushes the piston up, then the gas is doing the work, energy is spent, work is done by the gas, and the energy of the system it decreases because the energy is spent on doing the work. Energy of the gas decreases. Hence, work done by the gas is given a negative sign. So this is the sign convention of work. Let us see the two different types of properties, state function and path function. What is a state function? It is a function of the state. It is a property whose value depends only on the state of the system and not on the path taken to reach that state. It denotes an equilibrium state and depends only on the initial value and the final value. Examples are mass, pressure, volume, temperature, chemical composition, internal energy, enthalpy, entropy, free energy and density. They depend only on the state of the system. What is a path function or process function? It's a function of the path. It's a property whose value depends on the path of the transition of the system from the initial state to the final state. It gives different values to different paths. Example, heat and mechanical work. They depend on the path followed. Change in internal energy is equal to delta U is equal to Q plus W. So if it is a path function, like for example, you walk down a lane, you will spend a lot of energy compared to if you take a car and drive the lane, then you will spend less amount of energy. So the amount of energy you are spending is proportional to the path taken. So Q and W are path functions and delta U change in internal energy. This is a state function. So these are the two types of thermodynamic properties. So this is the basic introduction to terminology of thermodynamics. Thank you for a patient hearing, and if you like my video, please subscribe to it, and in the next video I'll come up with some more topics from thermodynamics. Thank you.